All right, so in this video, we're going to talk about example 2 from the notes, and we'll do it similar to the last one, where the first thing we'll want to look at is the graph of sine of x. The fundamental cycle for the graph of sine of x is from 0 to 2 pi, so that's what I'll go ahead and graph. Sine's bounded by 1 and -1, starts low, goes high, and then oscillates. So there's the graph of sine of x. Now, I'll go ahead and I'll take the inside, which was pi x plus pi over 2, and I'm going to bound that between 0 and 2 pi. Again, I'm doing so because the original parent function had a fundamental cycle of 0 to 2 pi, and we need to adjust that now. So if I subtract pi over 2, if I go ahead and subtract pi over 2 from all parts, that's going to give us a negative pi over 2 less than equal pi x less than equal 3 pi over 2. And finally, if I take both sides and I multiply by 1 over pi or divide by pi, however you want to view it, that's going to give us a negative 1/2 less than equal x less than equal 3/2. So again, what that means is when we come over and graph this now, our first tick mark is going to be at negative 1/2, and our last tick mark is going to be at 3/2. There's going to be 4 different intervals, and so what I would do is I would see that the distance from start to finish is 2 units. So if that's I'll put that up there so it's easier to see. So I've got 1.5 units here plus another half, so that gives me 2 total units. And then if I'm going to have my 4 intervals, 2 divided by 4 is 1/2. So each tick mark is 1/2 units away. So I might have to erase this to make it look a little nicer. All right, so let's see here. I've got negative 1/2. The next tick mark would be at 0. Then I'll have positive 1/2. I'll have a 1, and then I'll have my 3/2. So we've got 1, 2, 3, 4, 5. And we have 4 different intervals. 1, 2, 3, 4. And again, that's why we divided by 4 there. All right, so then the next thing that I'd look into would be this plus 1. Again, remember, their midline for sine is also going to be the x-axis. We're going to be shifting up 1 unit. So if we put this at 1, that's going to be then our new midline. Again, it's not really a part on the graph. It's just something that we visualize being there. Now, if everything moves up 1 unit, then if we look at just the 1/2, that's going to tell us the amplitude of 1/2 is going to maximize the graph at 3/2, and the minimum values are going to be 1/2. Okay? Now, the last thing that we're going to look at here is going to be the negative. The negative sitting out in front takes the sine graph here and flips it around. We normally start at the midline and go high. Now we're going to start at the midline and go low. So starting at the midline and going low and then back high all the way to the top and then back to the midline. So here you can now see how this oscillates between the 3/2 on the top and the 1/2 on the bottom. And again, there's that midline right through there. If you want to keep it marked, you can. Again, it's not part of the graph, but it might be helpful for you. So originally we started midline and went up. Because of that negative, we start midline, we go down, and then it continues to oscillate and wave through there. Now, in terms of other information that we would want to know from this graph, the domain, similar for all sines and cosines, you'll see a negative infinity to positive infinity. The range, here our low number is at 1/2, and our maximum value is at 3/2, inclusive on both of those. The period, the distance required to complete one cycle. As I mentioned, we've got 3/2 units there, we've got an additional half unit there, so the period would just be 2. The amplitude would be a positive 1/2. Remember, amplitude is always positive. And then finally, the phase shift. So you can see we started here at 0. We moved over to start our graph at negative 1/2. So you'll have a phase shift of negative 1/2. And kind of like I showed you before, if we just focus on this, by pulling out a pi, that's going to give us an x plus 1/2. And that right there, that's going to be that phase shift. Now again, by doing it like this, we don't have to necessarily see that, but it is important to point out.